When we look at a flat map, a representation of our spherical world flattened onto a two-dimensional surface, it's easy to fall into a common misconception. These maps, while useful for many purposes, inherently distort distances and shapes. It seems obvious at first glance. The shortest distance between 2 points is a straight line. A ruler laid across the map confidently confirms this fact, but in aviation, the real world presents a different picture. Flight paths are rarely straight lines as they appear on these flat maps. Instead, they arc gracefully, often curving significantly toward the north or south poles, depending on the origin and destination. Why this seemingly indirect route? Because our planet isn't flat, it's a sphere, a three-dimensional object with a curved surface. This fundamental truth changes everything about how we perceive distance. And the shortest route between 2 points on a sphere isn't a straight line on a flat map, but rather a great circle, which appears curved on a flat map due to the distortion inherent in map projections. These arcs aren't detours, they're not mistakes or inefficiencies. They're the result of meticulous planning, a careful consideration of the Earth's geometry, balancing not just speed but also safety, fuel efficiency, and other critical factors. Airlines must always consider the Earth's curvature, along with atmospheric conditions like wind patterns, the availability of emergency landing sites, and of course, fuel consumption. What looks like a longer, more circuitous route on a flat map is very often the fastest, most fuel-efficient, and safest path to take. The Great Circle route represents the true shortest distance, defined as a segment of a circle whose center coincides with the Earth's center, and therefore represents the most direct path between 2 points on our spherical planet. On a flat map, this Great Circle path appears as a sweeping, curved arc, often taking planes over seemingly remote locations like Alaska or Greenland. So the real question isn't simply why planes tend to avoid flying directly over the vast expanse of the Pacific Ocean, but rather, why they meticulously follow these specific, seemingly counterintuitive curved routes. The answer: it's not arbitrary. It's a carefully considered blend of scientific principles, stringent safety protocols, and smart, strategic planning. Let's delve deeper and explore why the Pacific's sheer vastness and unique characteristics makes it such a unique and challenging environment for aviation route planning. The Pacific Ocean isn't just large, it's the largest feature on Earth, dominating our planet's surface. Its sheer scale is almost incomprehensible. It sprawls over 60 million square miles, a truly staggering expanse of water. This immense area dwarfs many continents. In fact, it's wider than all the landmasses combined, a testament to its overwhelming size. Imagine trying to fill that space with land. Crossing it by air means enduring hours upon hours of flight, with absolutely no land in sight. It's a true test of endurance for both aircraft and crew, and there are no easy alternatives should something go wrong during the journey. Emergency landing options are severely limited in this vast expanse. Its remoteness is extreme, a factor that significantly impacts aviation and maritime activities. In some of the most isolated areas, the closest humans are often astronauts orbiting high above in space. That's how remote it is. For pilots navigating these routes, this translates to incredibly long stretches of flying time. They face these long stretches with very limited options for diversion in case of emergencies or unexpected events. Unlike the busy and heavily trafficked North Atlantic air routes, the Central Pacific presents a stark contrast, characterized by its vast emptiness. As a result, most flight routes tend to hug coastlines and strategically utilize island chains as stepping stones across this immense ocean. Flights often connect the dots, island hopping between these isolated landmasses. They also serve as vital links between the continents that border the Pacific Rim. This is all done to avoid the deep, empty heart of the ocean, a region of unparalleled isolation. The Pacific's sheer size and extreme isolation force aviation planners to treat it as a massive obstacle to be circumvented, rather than a convenient shortcut to be exploited. Only the most meticulously prepared and well-equipped flights dare to cross its vastness directly, and even then, they do so only along carefully planned and rigorously maintained corridors. The Pacific in many ways is a blue desert, an aquatic wilderness. It's a region crossed only when absolutely necessary, a testament to its challenging nature. This reality profoundly shapes every single decision made in trans-Pacific flight planning, from route selection to fuel calculations. The Earth's shape dictates flight paths. The shortest distance between two cities is a Great Circle route. On a globe, this path arcs northward. Flights from Los Angeles to Beijing, for example, pass near Alaska, not straight across the Pacific. These arcs save time and fuel, making them the logical choice for airlines. Flight planning software instantly calculates these routes for efficiency. Most major city pairs in the Northern Hemisphere are connected by these polar or near-polar arcs. It's not about avoiding the Pacific, but following the laws of geometry. The Great Circle is the foundation for every long-haul flight plan. All other factors, weather, safety, economics, build on this principle. Safety is paramount in aviation, a critical consideration. In emergencies, pilots need to land quickly at a suitable airport, of course. Regulations like ETOPS require twin-engine planes to stay within a set flying time of a diversion airport. The Pacific's vast emptiness makes this difficult. Few islands have runways capable of handling large jets. Flights are planned to stay within range of airports like Honolulu or Fiji, creating specific corridors. A direct Central Pacific crossing would violate safety rules for most aircraft. The lack of emergency options makes much of the Pacific a no-go zone for commercial flights. The safest route is always chosen, even if it's longer. In aviation, safety is never negotiable, absolutely not. The atmosphere is alive with jet streams, fast, high-altitude winds that circle the globe. Flying with a jet stream is like riding a river current, boosting speed and saving fuel. Eastbound flights like Tokyo to Los Angeles seek out these tailwinds for faster journeys. Westbound flights avoid headwinds, sometimes taking longer, more northerly routes to save fuel. The path chosen balances distance with wind conditions. Jet streams are strongest in the mid-latitudes, aligning with great circle routes between North America and Asia. These winds shape flight paths as much as geography does. The weather route can be more important than the geometric one. Pilots and planners constantly adjust to harness or avoid these invisible rivers. The result: efficient, ever-changing arcs across the sky. Airlines are businesses' fuel, and time are their biggest costs. The most economical route isn't always the shortest on a map, but the one that uses the least fuel and time. Taking advantage of tailwinds or avoiding headwinds can save tens of thousands of dollars per flight. Risk management is also key. Flying within ETOPS range reduces the chance of costly emergencies. Insurance, safety, and efficiency all factor into route planning. The safest, fastest, and most economical routes often align over the northern Pacific Rim. The Central Pacific is avoided not out of fear, but because it's less profitable and riskier. Every arc is a product of careful calculation. The result: routes that maximize profit while minimizing risk. Real-world flights, the kind that crisscross our skies every minute of every day, show these principles in action, demonstrating how complex calculations and real-time adjustments come together to guide aircraft safely across vast distances. Take, for example, a flight from San Francisco to Hong Kong. Notice how it arcs north over Alaska, a seemingly indirect route. This path is chosen deliberately, taking advantage of powerful jet streams that can significantly reduce flight time and fuel consumption. The route also prioritizes safety, staying near diversion airports in case of emergencies. Consider another long-haul journey: Los Angeles to Sydney. This flight crosses the Pacific, a vast expanse of water, but the chosen path is always near Hawaii and other islands, providing crucial options for emergency landings. This proximity to land masses is a key factor in ensuring safety for all passengers and crew. Even the seemingly isolated Santiago to Auckland route, traversing a remote stretch of the Pacific, adheres to the principles of a great circle, the shortest distance between 2 points on a sphere. This route is flown by aircraft maintained to the highest standards and equipped with the latest safety technology. Every flight, no matter how routine it may seem, is a delicate balance. It's a complex equation involving geometry, constantly changing weather patterns, stringent safety regulations, and economic considerations. The Earth's roundness dictates the shortest path, while the power of jet streams offers opportunities for faster travel. And the ever-present need for emergency options shapes the routes we see in the sky. These factors, working in concert, all shape these elegant arcs. The Pacific's vastness, a seemingly endless expanse of water, demands respect, meticulous planning, and a deep understanding of the challenges involved. The beautiful, curving flight paths we see, etched against the blue sky, are not arbitrary. They are the elegant solution, born from careful consideration and advanced technology. They represent the answer to a complex puzzle, solved by dedicated professionals and sophisticated systems. Planes don't avoid the Pacific out of superstition. There's no mystery here, just sound reasoning. Instead, they follow the smartest, safest routes, guided by data and expertise. These routes are also the most efficient, minimizing fuel consumption and environmental impact. Modern aviation is a triumph, a testament to human ingenuity and collaboration. It's a story of science, unwavering commitment to safety, and strategic thinking on a global scale. The arcs in the sky, those graceful curves we often take for granted, are the signature of our mastery, a symbol of how far we've come in understanding and navigating our world. They represent our ability to overcome distance and danger, connecting people and cultures across the globe.